Hey there, I'm Stewart, an architecture professor and a designer. And it's the beginning of summertime here in the Midwestern United States, and I've traveled all the way up here from Chicago to a cabin in northern Michigan to practice my firemaking skills. You see, fire is an important part of architectural design, and in this video I'm going to walk through how to make a fire like an architect and offer some poignant architectural examples of how fire shapes the designs of buildings in general, so stay tuned. Fire is an often overlooked but essential driver for the design of buildings. People like the theorist Gottfried Sempter, he even argued that fire is what spawned the beginning of architecture and even the beginning of society itself. People would gather around a fire, and it thus becomes the central space for gathering and community. It offers a certain amount of thermal protection for the group, and then the fire and the group itself needed additional layers of protection, which was given through the construction of a shelter, which in turn becomes architecture. In addition to providing social gathering and thermal regulation, fire is also important to cooking, which is an essential domestic activity. So as we shifted from nomadic to agricultural societies, fire was a central feature in most houses. However, over time, with technical advancements, the fire eventually moved toward the edge of the home, where it could be exhausted more easily. Until finally, today, where we have fireplaces which are seen more as like a luxury item than as a necessity, and they mostly just give an aesthetic experience rather than some true functional performance in most cases. However, even today, fire shapes the spaces in the buildings in indirect and direct ways. Fire codes govern everything from the sizes of buildings to the configuration of rooms to the materials that we use and how they're assembled. We even have fires burning in our homes even when we can't see them. Pilot lights, or the little blue flame that burns in our furnaces and boilers, are hidden away and ready for whenever we need them. But right now, my task is to gather up some wood in various sizes to be able to construct this evening's campfire. Wood. Wood is an extremely popular material for construction, especially here in the United States. It's strong, it's plentiful, it's renewable, and it doesn't require a ton of expertise to make a building out of it. Wood construction can take many forms. Of course, entire logs could be stacked to form log cabins, and here the wood is used more like masonry or like bricks. But however, we don't really have the kind of resources to use the material this intensively anymore, so we cut wood down to use as frames. And depending on the size and the spacing of the frames, we might have light wood framing like 2x or timber framing. Because wood is so flammable, its use is very specific and regulated inside of the building industry. It's also historically been limited to smaller buildings, especially homes. However, more recently, with chemical treatments, supplementary fire suppression systems, and other innovations, multi-story housing made out of wood framing has become possible. Even more, other wood products like cross-laminated timber have even led to skyscraper designs made primarily out of wood. And in these buildings, fire is an important design determinant to ensure that the safety of its inhabitants. Fire codes are really determined by three main factors: building size, programmer use, and the materials used in construction. All of these factor into how many people will be evacuated in the event of a fire, and how much time they have to do so. There are a number of model codes that are referenced and adopted by various jurisdictions, and the National Fire Protection Association, or the NFPA, is charged with setting standards for fire prevention and other life-saving emergency endeavors. These codes developed over time in response to various fire events and are written with the goal of providing reasonable protection of life and property from the hazards of fire and explosive materials. Fire codes exist to minimize hazards to life and property from fire and panic.
Of course, Chicago, the city I drove up from, is notoriously shaped by fire. There's the Chicago Fire soccer team, Chicago Fire TV show, which sometimes films in my building. Even the school where I'm employed is called the Flames. The Great Chicago Fire in 1871 spread from Mrs. O'Leary's barn to cover 2,000 acres of the city. It cleared the way for skyscrapers to take place of the smaller building stock of old Chicago, and it led to stricter codes governing how we construct our buildings today. This is one of the reasons so many buildings in the city are built from brick, limestone, or terracotta. In addition, streets were widened, and walls between buildings, or party walls, had to have increased fire resistance.
My fire building technique is called the log cabin method, or the crisscross fire, which relies on stacking the wood in a square of alternating layers. You start with the unchopped log as the foundation. These ones are tall enough to allow for the kindling in the center, and these logs burn very slowly to maintain the integrity of the fire for as long as possible. These ones work much the same way that timber framing works in buildings. Timber framing has a unique way of burning that actually makes it perform quite well during a fire. Due to the large size of the units, the outside burns first, which forms a crust of burnt charcoal that is no longer directly flammable. This crust allows for the timber to retain its structural capacity for quite some time, becoming almost fireproof in the process.
There's a chapel by the Swiss architect Peter Zumthor that uses fire and wood in its construction in a really unique way. It's called the Bruderklaas Field Chapel, and it's basically a solid chunk of concrete. But on the interior is a space left over from the pouring of the concrete over wooden sticks that were bound tightly together and used as formwork. The poured concrete didn't seep through the layer of the wood, but the wood also couldn't be pulled out after it was poured, so they burned it all away. That was the plan all along, and the char left by the process leaves a beautiful and eerie materiality on the interior.
Now is the point where we start to stack the rest of the wood, and here we need to make sure of a couple different factors. First, we go from the largest pieces of the wood at the bottom to the smallest at the top. And the cut face always needs to face the interior of the fire so as to catch fire first. Also, we should be stacking in such a way so that the upper members are offset to the interiors of the ones below. All of this sets up a condition where the upper ones will catch fire simultaneously with the lower ones, but the top ones burning off at the quickest. The entire assembly also collapses inward in a very predictable manner. Design for fire in buildings follows a similar line of thinking. It's not necessarily about making buildings fireproof, although some are. It's about controlling the method of burning to slow it down and prevent it from spreading, and to keep people safe while they evacuate and fight the fire. Basically, it's to control the fire so that it can become predictable. With wood stud framing inside of buildings, we rely on the entire wall assembly to provide fire protection. The sandwich of materials is given a fire rating, which is an interval of time. A typical interior wall of 2x4 studs sandwiched between layers of drywall is not usually rated, but it might last about 30 minutes in a fire. At critical barriers between spaces, like around stairwells or between buildings, the code might call for up to an hour or 2-hour fire rating, which means that it can resist the exposure of a standardized fire for 1 to 2 hours. This can be achieved through a number of different factors, including layering up of drywall, which is more fire resistant, or using fire resistant treatments and coatings. Now is the time for lighting the fire, which happens at the base of our setup. If performed correctly, the design allows you to easily light the fire from outside of our cabin construction. The construction should also provide protection from strong winds while the fire builds, but at the same time allows for sufficient and directed air to flow and feed the fire oxygen. The larger logs at the bottom allow for air to be sucked up underneath, and then when heat rises through the top of creating a kind of suction of airflow throughout the fire. There are a couple of different principles here in action that dictate the way that the air flows through, and one of the most important is Bernoulli's principle, which talks about wind speed differences to move air. Architecturally speaking, the outdoor air further from the ground is less obstructed, so it moves faster than the lower air, and thus produces a kind of low pressure zone. This low pressure zone then can suck fresh air throughout the fire or the building. And this can be useful if we're talking about gentle breezes through a building, but where fire is concerned, we need to prevent this accelerated airflow, which can spread the fire. Fire blocking is the term for barriers between floors and between a top story and a roof or attic space, and it's used to slow the passage of flames and hot gases through a structure. According to IBC Section 717.2, fire blocking is required in combustible construction to cut off vertical and horizontal concealed draft openings. Fire blocking is related to, but different from, draft stopping, which prevents the flow of hot air and smoke through a structure. It is used to subdivide floor and ceiling assemblies according to IBC Sections 717.3 and 717.4. Draft stopping is installed so that horizontal floor areas do not exceed 1,000 square feet, and attics or concealed roof spaces are 3,000 square feet or less. Therefore, it is installed in drop ceilings, plated floor trusses, and roof framing. Finally, we're able to enjoy our fire. This is definitely not a kind of minimalist fire. This is not the kind we would make if we were out in the forest and had to rub sticks together. This is kind of like a perfect conceptual fire. And if everything goes according to plan, then it will burn for over an hour without much maintenance. And it will burn quite hot and completely. And then when you're through, you just grab your 5-gallon bucket that's handy and dip it into the nearby lake and douse it until it no longer smokes. Of course, buildings can have fire suppression systems in them as well. Using water pumped through a sprinkler system is the most common. However, it's also not the most effective kind of suppression system for every single circumstance. In some instances, water can be more dangerous in the presence of certain types of fires than other available extinguishing agents. It can also cause extensive damage to your property or equipment, require substantial cleanup. There are other options if those drawbacks are too much for you, and you can use chemical or gaseous fire suppressants. Inert gases work to smother fire by displacing the oxygen in the room, and this is useful for rooms with sensitive equipment. Carbon dioxide systems are also possible, but could be harmful to its inhabitants, so it should be limited to unoccupied areas of the building. And while I'm really enjoying this fire, I want to thank all of you for watching. And if you enjoyed this video, if it made you feel all warm inside like it is me, please consider giving it a thumbs up. You might also enjoy a video that I made on professional development lessons that one can learn from the movie Indecent Proposal, or the one on how all good architecture leaks. Leave a comment below with some of your favorite fire codes, and finally, hit that subscribe button. And if you want to be notified every time that a video comes out, hit the bell. Subscribing isn't enough to make sure that you see all the videos. So that's it for now. See you all next time.